All right, guys. So let me start off. I'm going to see if anybody else has any other specific questions, and then I have a question that a few people asked me earlier. Anybody else have questions from homework stuff? It's making me nervous. It's very strange if no one has questions. I mean, a few people asked some questions in office hours, but
I was just going to say, I asked my questions in office hours.
yeah, I'm with you. You're fine. I'm not talking about some of y'all that showed up for office hours. There we go. Don't worry, Anand. I'm going to come back to your question. I'm just sort of waiting for more people to get 95 from 4-3. All right, so that's this one. This guy here, right? Phew. All right, yes. So more than 96%, blah, 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 blah. Now, this is a little evil that they put more than 96%, but we're going to have to assume that they mean 96. Oh, real quick. The quiz today is only on chapter 4. So uniform distribution is from section 5.1. So it's not going to be on the quiz today. Today it's going to be X, P of X stuff, and binomial distribution stuff. Oh, am I looking at the right problem? I know I already forgot. Is it 95 or 96?
Yeah, you're looking at the right problem. It's 95.
95. Thank you. Thank you. So we picked 13 institutions. So I can already identify the key players. So there's 3 key players for a binomial problem, right? What's 13? What variable is that going to be?
N.
N. And what's 96%?
P.
P. And so what's Q going to be?
4%.
4%. Be very careful. 4% is not 0.4, right? I wish it was. I got a 4% bank account and they calculate it at 0.4. I'm like, yeah, that's 40%, dude. So that'll throw the whole thing off like insane. You'll get crazy ass numbers. So don't do that. So which part did you have trouble with? Let me see. Oh, you just the whole thing? Okay. All right.
Whether to turn it into a decimal or keep it how it is.
Oh, you definitely turn it into a decimal.
So I would turn it into 0.96.
Oh, always.
And the other one would be 0.4.
That's what I just said.
Okay.
4% is what? It's not 0.4. That's 40%.
0.04.
There we go. Sweet.
Okay.
Yeah. Is that the only thing that gave you trouble?
I didn't ask for this question. I was just asking from what you
I'm sorry.
Sorry.
I'm not even keeping track of who's asking what. E and F gave you some trouble. Okay. So what does that most 10 mean?
Kind of under.
Yeah, exactly. 10 and under, right? So if you're going to be at most 10 to eat off the kids menu, you can't be over 10. You got to be 10 or under. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to do that many formulas. It would work. If you do the formula for 0 and the formula for 1 and the formula for 2 all the way up to 10 and add them all up, it'll work. What's a slightly quicker way to do that? I'm going to change this over here. Anybody?
1 minus 11 through 13. The probability of 11 through 13.
What just happened? Sorry, hold on, guys. I gotta get this on the correct monitor because my pen only works on one monitor, which is so exciting. Just to make sure everybody's with me. And this is timely because this is what today's quiz is going to be on partially. So in this problem, number 95 in section 4.3, we've identified N is 13, P is 0.96, so Q desperately must be 0.04. And then we have a question. This question, this question we're going to address in a minute, because this question shows up in a lot of places. So give that a minute. I'm looking at E right now. At most 10, so the probability of at most 10 would involve that formula. What formula am I talking about? This crazy formula here, right? Over there, see it? Over this way. Am I right here? Is that where I am? Anyway, I always got to remember, I think I'm right there when you look at the screen. So I don't want to write up there. Let me stop for a minute. You guys with me? This is the formula for figuring out binomial probabilities. So you could do that formula for 0, 1, 2, all the way up to 10 and add them all up. Or you could do, like Sophia said, the opposite of this, which is greater than 10. So 11, 12, 13. I've only got to do the freaking formula 3 times then. So if I put 13 choose 11, P to 11, Q to the second, and I do that for each one of these, I can add those up and subtract it from 1 because they are opposite probabilities. How's that? Who's got some trouble with that? Anybody? So you would do probability of 11, which would be 13 choose 11, 0.96 to the 11, 0.04 to the second power, and you would add that to 12 and 13, and that answers the opposite of the question. Right? So the person asking the question gets upset for a second, and then you do 1 minus that, and then you answer their question. So get off my back. Maybe, maybe? Maybe.
How come you put 4 and 2 as what you're multiplying them by in the equation?
Oh, I'm sorry. This is not
That's
4.
supposed to be 11.
Oh,
It's 11.
sorry. Okay.
It just got very small over there.
You're okay.
Yeah, so, yeah. I want to remind you guys that, oh shit, okay, I got to keep track of that. Another question. As I pointed out several times, this book is based on a little too much, on the calculator. So these are fine to use to check your work. They do not count as work because you ain't doing shit except pushing buttons. And this is not, Math 160 pushing buttons class, right? So this is why if you got your homework graded and I crossed through this and I said redo or something, that's what went wrong. You're not showing me your work. You're just telling me the work you're going to feed into the calculator. No. Show me this. And then something that I need to talk about. Oh, by the way, the question was also about part F. You just have to figure out, you're going to have to figure out those probabilities anyway. So then part F becomes really easy. You just see which one's more likely, right? Just got to look at both of those. So part F is nice. All right, so here comes the uncomfortable talk, kids. I'm seeing way too much questionable activity on homework, which is really getting me down, but that's all right. I'll work through it. So from your end, That's not good. If you do that too often, I'm just going to say you got a 0 on homework. Stop giving me stuff. Good luck. I'm not here to grade the solution manual or anything like that. I also see what looks like some cross-pollination between people's stuff. It's okay if you work in groups, but there seems to be a lot of, for example, there was, oh, I should have written it down somewhere. There's one problem, I remember it now. Here, I'm gonna stop sharing this. You guys got all this stuff here? Or anything you want from that? You guys good? Okay. So there's a problem in the homework that leads to this work. Let me see if I really remember this. No. Well, it leads to this work because this is wrong, but the way that some of you guys set it up, it leads to this work. Let's see, what was it, minus 20. And somehow you got, now if you put this in the calculator, what's 150 divided by 100? It's 1.5 plus 0 minus 20. Are you guys with me? Now, some of you guys might recognize this. Some of you guys might sort of recognize this and realize it's not really the right answer. This is the one about the Broadway tickets. I think it was, maybe, or something like one of those kind of things where there was a possibility to win something. Yeah, I think it was the Broadway tickets. You bought 4 tickets, they were 5 each, so that's minus 20. What is 1.5 minus 20? It's definitely not negative 14. But I had several people that had this exact setup and got the right answer from bullshit. So that's bad, right? So I don't know if it was independently gotten from something or if you all work together, and whoever you picked to copy from, you might want to pick somebody else because they're not sure what they're doing. Okay. So I much more respect the person who is doing not very good on their homework, but the entire thing is honest, right? And you're really just shooting yourself. Even if I don't catch it, you're just killing yourself. You got to know what to do or else you're going to die on the quizzes and the final. Okay. So good. And by the way, the rest of you who are honestly doing your work, I appreciate that. I'm not coming down on everybody, but there are people and you know who you are and you better stop, or else I'm just going to give you a 0 for the homework and that makes my job easier. But I don't want that. Okay. Let me see.
I had a question.
Yes.
So you were talking about showing work. How do you want us to show our work for the problem for like 95? Like I know I wrote out the equation and everything and like put that on, but how do you like, is that showing the work?
So equations, so you set up all the equations and then you throw those in your calculator.
Okay, so that's
You don't have to, there's no way in hell I'm going to make you do 98 choose 3 and show me all that. No. So you need to understand that showing your work, sometimes it means doing long division. That's not going to be in this class. We are way past that shit. Showing your work in this class will mostly be either showing me the formula and you plug the stuff in the formula and then you put that shit in the calculator, that's fine. Or showing me a table and you identify what each piece is and then you throw it all in the calculator in the lists, that's fine. You guys see what I'm saying? That's the work I need to see. You obviously don't have to do 0.07 to the 87th power. 0.07 times 0.07 times 0.07, 84 more to go. Here we go. No. Good Lord, no.
Okay,
All
I just wanted to be clear on what it was, just so that I like what I know. Okay.
Okay. All right. So I got another question from page 94. I'm sorry, number 94. F. Okay. Oh, So they keep asking this kind of question. So figure out what the probability of 3 is and figure out what the probability of 4 is, and then see which one is more. That's all. Is that all right?
I was just wondering, but though, since this one is like, this is the dice, right? Wouldn't it be like the same? Like, don't we just know it's the same, like right off the bat, though? If like,
Why?
because they all have like an equal amount, the same amount of chance of happening. And it's like, if you get, it doesn't matter what the number is, it matters like how many times, like the probability. So like, for this one, I thought like, if it's just like, let's say like you have a dice and there's like 1 through 6, you have a as equal chance of getting a 1 and a 6 kind of thing.
Oh, I see. Okay. This is beyond that, though. How do I say this? I mean, did you do the formula and show that they're equal? You'll find out that they're not.
Oh, okay.
So think about it. What's the most, if I roll 6 dice, how many of them would you expect to show a 1? This is
From guessing or just like from a, like the
no.
actual.
This is going to the actual basic definition of what probability is, which doesn't mean you should feel bad if you can't immediately answer me. It's just, this is what probability means. What's the chances that a die shows a 6? Shows a 1. I got 6 in the brain. What's the probability a die shows a 1?
1 out of 6.
1 out of 6. I love it. So, and in fact, didn't you? Yeah, you already did part D. I'm sorry. What's the answer to part D? How do you figure out on average how many dice would you expect to show a 1? You would do n times p, right?
Yeah.
So 6 times 1/6 equals
1.
1. So does that make sense? Because on average, I would expect 1 out of every 6 to show a 1. That's exactly what that says. Because the probability of a 1 is 1 out of 6. Do you see how that beautifully lines up?
Yeah.
Okay. Therefore, the further you get away from 1, the less likely it should be.
Oh, okay.
It actually should be more likely that 3 rather than 4, but I want you to, it says use numbers, so you do the formula and you show that that's true.
Okay, got it.
I mean, the least likely thing would be on the order of all 6 are 1s, right? And that's like part E.
Got it.
Yeah, okay.
Am I allowed to ask another question as well?
No, yeah, of course you are.
Sorry, I just want to make sure we're on time. I was wondering about like, I only just started looking at this 5.15.
Oops. Oh, practice. Number 5. Yeah, so the thing about this is kind of like, I talked to you guys about triangular shapes, right? So this is not even, don't worry, you're not going to have to calculate this probability. It's just, if you were able to do this one, I think that's the one I assigned, you have to be able to do this. It's just saying, what does this represent? The probability from what to what? That's all it's saying. You don't have to calculate it. It's a weird shape, but who cares?
Okay, got it.
Cool.
Thank you.
You're welcome.
I have a question too.
Sure.
Can we go back to 94 and talk about C?
Oh yeah, okay, beautiful. Perfect segue. So let's talk about this thing that's up on the board. Let me stop sharing. So you're going to see this question throughout the next 3 chapters, at least. Describe the distribution or identify the distribution, whatever the shit. What distributions do we know so far? Chapter 4 included what kind of distribution? The problems we were just doing.
Binomial.
Binomial. So I got binomial. That's a B. That B has been eaten too much. There you go, buddy. What's the one that we just learned about in chapter 5?
Uniform.
Uniform. And then what's the one we're about to learn that was on my shirt Monday, I think? You remember?
I just remember the ghost.
Normal.
Normal. I like it. Fun. All right. So when they say X follows what, and they got like this, what you want to do is you want to put a B if it's binomial, and then what two things? What are the most important two things to know for a binomial distribution?
P and Q.
No, I don't have to know both, do I? If you tell me P,
N
can't
and
I
P.
figure out my own?
N.
N and so if I had a binomial and N was 6 and P was 1/6, that's the one. Why did I do that? There's a gimme answer for you, right? N is 6 and P is 1/6. That's the one with the dice. So if I had a uniform, what's the two most important numbers to know for a uniform? You can do it. I can't do shit. So
The lowest and then the highest value of X.
kick ass. And they call it A and B, whatever those are, right? So that'll be A and B. And for a normal distribution, we'll learn today it's mu and sigma. Good old mu and sigma are coming back. So when they ask a question like X, describe the distribution, or they have a problem that says X goes like blank parentheses, that's what they mean. Identify what type it is and the two most important things about it. A lot of kids. Okay. Is that okay? Is that okay with everybody that was asking that question?
Okay, so for that, you would put binomial, and then you would put the number, and then P. Okay,
And what's P represent?
the success or no?
Yes. Probability.
Yes. Okay.
Okay. All right. Anything else real quick before we get back into sort of like where we left off? Okay. All right. So what we're going to do, so just to kind of remind you a little bit of a few different things we've done throughout the semester, because chapter 6 is the most important chapter in the book. No pressure. All right. So one thing I want to remind you about, let's see. There. Oh. You will work for me. Okay. Let me see. Which order should I do this in? Oh, all right, let's do this. The probability of a situation, if I draw that situation on a visualization of the distribution, oh my God, that sentence was so dense. If I create a visual of the distribution, so here's a uniform distribution, and I identify all the stuff, and I draw in a question somebody could ask me, the probability it goes from C to D. The probability is equal to the area related to the question. That is always true. So we didn't do a problem like this because it's not part of what we do, but if I had a distribution that was triangular, and I made the area so that it was 1, you got to figure out what the height would be, I could then calculate trapezoidal areas from whatever to whatever, right? It would, if I find that area, I found the probability from this to this. So if I have a visualization of a probability distribution, and I make the whole area 1, the probability of a piece of it is equal to the area of that piece. That kicks so much ass. Especially when I have freaking rectangles. Even trapezoids wouldn't be that horrible. Okay. That's one thing. The other thing is, do you guys remember? All right, so here's our normal distribution. And you are all over the place. I don't know. All right. So if I go down 1, up 1, does somebody remember what percentage was in here?
68.
48.
68. Good try. 68% there. Anybody remember what was out here?
95.
95%. And then 3 would be 99.7. Okay. So can somebody tell me, let me see if I can push this a little bit right now. Just based on what I've put up there, can somebody figure out what this area is right there? Remember if we did this.
5%?
2.5.
Almost.
The 2.5%.
2.5. So this is 95%, which means this total is 5%, which means that's 2.5%. Let me stop for a minute. So this is 95%, which means there must be 5% outside, which means that side is 2.5%. All right. Now don't say anything. Let's do one more of those. What's here? I gotta stabilize you somehow. I don't know. Rawr.
$13.5.
Say it one more time, sir.
13.5.
17.5?
No, 13. 13.5.
13.5, okay. So there's an option, 13.5%, possibly. Anybody else get something different?
18.5.
Say again.
18.5.
18.5. So we got an 18.5. So one way to do this, this might not be the way you did this, but what percentage would be here?
$34.
34%. And what percentage would be, oh, this is getting too messy. Let me redo this. So I want to focus between here and here. So this was 68%. So this is 34%. Let me stop right there because the mean cuts the whole picture in half. So that makes sense right there. What would this be? Well, this is 95%. So what would this be? Shop. 47.5. So how do I figure out what just this much is? I would do 47.5 minus 34 would leave me with just this much, right? Let me stop for a minute. If I did 47.5 minus 34, wouldn't that leave me with this much?
Yes.
So that's 13.5. Yes. All right. Now, some of you guys might be happy to know that we're not going to be doing that a lot at all. But I do want to have that there for the next thing I'm going to do. just to kind of get you to buy into what we're about to do. Knowing this is really useful. But when I have a shape like this, the little shapes I make when I want to figure out areas, they are not something in our normal geometry, right? There's no geometric formula for the area of this shape. There isn't. Well, there is, but it's nowhere near nice. It involves calculus to figure out. So what I've got instead is I've got a whole list of all the answers for every problem we're going to do. Isn't that nice for me to do? You just have to find them. Ha, 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 ha. They're all in there. It's sort of like a word search. Let me see. So what the hell am I talking about? I never know. So here, let me show you where this is. Oh, let me move it over here and move you guys over there. Put this up here. Do this here. It's just that easy, kids. All right. So if you go to modules, I have added in fact, this is up here on Monday. Unit 6 down here. Z-scores. Oh shit. Remember good old Z-scores? In fact, that's what those are. That's the other thing I was going to say earlier. You can't see this anymore because I'm tiny. I'm sorry. But the 0, 1, 2 in that picture, those are Z-scores, right? That's how many steps away. So here's how they have decided to order this thing for us. So what the shit does all of this mean? Well, any Z-score I look up on this, this will tell me the area below it. So let's do one that I should have done one that was directly related to, in fact, real quick, let me stop sharing for a second. And by the way, if you can, go into Canvas and pull this bad boy up for yourself, right? So it's under modules, and then unit 6, Z-scores, bam. So answer me this real quick. Let's see if you guys can get this. This will be real quick. This was 2.5%, right? So what's this? What's over here?
2.5%.
2.5%, same thing. And that's the area that is below -2 Z-score, right? Right? That's just what it is in the picture. How much area is below -2 Z-score? 2.5%. Rounded. All right. So let's look at this chart and see how the shit do I read this chart. Notice how this chart works. If I want -2.00, so this row here is the second decimal place. So if I want to look up -2.03, I would go right there. You guys see? So look at -2.00. What do you get?
0.228.
Yeah, 0.0228 is like 2.3%, which is pretty close to 2.5%. So in the empirical rule, we rounded those numbers, and then the 2.5% we got from those rounded numbers. So of course it's going to be close. So let's do this. This is going to be very strange for me. How am I going to do this effectively? Let me think. Well, yeah, I guess I could do that. All right, let's do this. So I don't have to keep going between this and the board. Let's see if this works. So watch this. If I do this, it means I can't see everything. That's too bad for you, Jeff. Oh, you're so nice. All right, so what if I want to know, oh my God, the area that is below -3.01. I want to know this area right here. So any z-score that you look up, when you, so negative 3.0, and how do I get to 1? Negative 3.00, negative 3.01. There's negative 3.01 right there. So there is 0.0013. There is 0.13% in there. So let me make this a little more interesting. If I have heights of US men, the average is 69 inches, and the standard deviation is like, let's say it's 2.5, just to make this easier. All right, so let me write that down. The average is 69 inches, and the standard deviation, let's say it's 2.5. I think it's really 2.8, but oh well, too bad. Is everybody cool with that? That's just the average in the standard deviation. So what's one step down? What amount is one step down from the mean?
66.5.
Yes. You just got to subtract 2.5 from 69. That's how I go one standard deviation down. So let me erase that little arrow. Get out of my way, little arrow. No, I made too much. What is it? I just lost something. I don't know what I just lost.
0.5.
Oh, thank you. Okay. So this, underneath this is going to become very useful to us. I'm going to put a 0 and a -1. What do those represent?
Standard deviation.
Yeah, the number of standard deviations from the mean, which is also very quickly known as
Z-scores.
okay. like I just don't know, Jeff. I don't know what your point is. So how many men, how many US men, what percentage of US men are less than 66.5 inches tall? No, good job, Jeff. I didn't mean to just stop there. I can't even see the bottom of my damn chart. But if you got the chart pulled up, I'm gonna have to.
0.4602.
All right, say it one more time.
0.4602.
All right, that doesn't sound right. Let's take a look here. I'm gonna have to stop sharing. Hopefully you guys got this copied down here. I can't scroll down unless I delete this. Well, actually, no. Can I move down? Yes, I can move down.
No,
so
it's 0.1587.
There you go. There's a late. I will accept that friendly amendment, and you got that right. If I look up -1.00, there's 1587 right there. You guys see it? So let's do this. So that's a real life example of what the shit this is all about. So there is almost 16% of U.S. men are less than 5'6.5". Almost about 16%, right? 15.87, whatever that was. Let me stop for a minute. I just wanted to bring in a real life situation to really get an idea of what this is telling me. So any situation I have, if I change them into z-scores, I can look that up on the chart and see what percentages there are. That is unbelievably useful. So let's do this. I'm going to clear all my drawings here so far. Gone. Scroll down a bit. Look down. If you go down further, there's positive z-scores, of course. Right? So I got some space over here. Oh, why did that? The formatting's kind of weird, but no, you can still read it. Good. All right. So let's try a problem or two out here real quick. So can somebody tell me, whoa, so here's the first problem. What's the probability that Z is less than 1.17? So you're going to draw the picture. You're going to shade in the area I want. Does that make sense? Less than 1.17. I want that whole area. So you already know the answer is more than 50%. That's a huge area. So what's the probability Z is less than 1.17? I have to remember to look at this. What does that do when I do that?
0.8790.
Yeah, so there's 1.1, and then I got to go over to 7. There's 1.17, so 0.8790. That is how big this area is. It's almost 88% of the whole area. So 88% would have a z-score less than 1.17 in a normal curve. So this whole thing only works for normal distributions. Okay, so what about this? What is the probability that z is more than 0.83? So do two things for me. Try to draw that and shade in the area, and then try to figure out what the hell that is. Don't say it out loud. Keep it to yourself. So the thing that always goes in the middle of a normal distribution is the mean. And what's the mean for z-scores? 0. So where's 0.83? This always drives me a little crazy. People just throw shit down here, but 0.83 has got to be in a certain place. It can't be over here, right? This is negative. It's got to be somewhere over here. And where's the area that this wants?
On the right side.
Yeah, wants this area right there. So you already know, visually, you know it's less than 50%. So what do you get when you look up 0.83? What do you get?
0.7967.
Yeah, so right there you get 0.7967. That cannot be the answer for two reasons. I already know visually it's less than 50%. And every single number in here relates to the area that is where?
From the left.
The area that is below. I like it. That's to the left of what you look up. These numbers automatically go in below the z-score you looked up. So this 0.7967 is that area. So how do I find the area that I want?
Subtract from 1.
Yeah, dude. Yeah, both of you dudettes. I've been sort of getting you ready for this, right? We know the opposite of what I want, so then I just do 1 minus that. And the shortcut is, makes it a 10, makes it a 10, Jeff, a 9, makes it a 9, makes it a 9, make the last one a 10. Woohoo! Can you guys tell me honestly right now, can somebody, who is not able to pull this sheet up for themselves right now? Anybody? Can everybody access that on Canvas right now for yourself? Okay, I don't see anybody telling me they can't. Of course, I don't have any clue how many of you that are black boxes with names are actually there or just back in your bed. I don't know. I'm going to assume you're there. So what I'm going to do is in a minute, I'm going to stop sharing since you all can see it. Can somebody take a second? Can you go up and look at negative 0.83? If you can access your chart, look up negative 0.83. Look up that z-score up here on the negative side, right? What do you get when you look up negative 0.83?
0.2033.
Holy shit. And why does that only make sense? Well, let me draw it over here. Maybe a different color, Jeff. That blood red is kind of starting to wear on me. Let's do forest green. Yeah, all right. So if the area for negative 0.83, if the area below it is 0.2033, then obviously the area above positive 0.83 is the same thing because it's symmetric, right? The normal curve is symmetric. So there is a bit of a shortcut in what I just talked about. If you don't get it, it don't matter worth shit because it ends up saving you about 3 seconds. So it's up to you.
So
if you like.
basically, it would be if it's asking if it's greater than the z-score, you could just look at the negative.
You can look at the opposite sign.
Okay.
Yeah. So if it was like z greater than negative 1.87, you look at positive 1.87. But if you don't completely get that, never use it. Because you might use it places you really shouldn't. All right. You don't ever have to use that shortcut ever. So if you don't want to, don't do it. Let's do one more, and then I'm going to let you guys work on a little sheet. Uh-oh, there's a chat. I can't handle all this. Re-explain how you figured out the 0.83 example. Okay, so this right here is what's the most important to understand right now. When you look up 0.83, I get right here. Is that cool? 0.83 is that area, no question. But this chart designed to tell me the area below what I just looked up. So this chart, the reason it's only 2 pages is because it's so single-minded. Anything I look up, it tells me the area below that. Is that part understood?
Yeah.
All right. Spokeswoman has spoken. I like it.
Which your microphone.
Now, this question doesn't give a shit about that number because it wants greater than this. So how did we get this? Well, it's got to be 1 minus this. We did 1 minus 0.7967 to get that, which is what I've been getting you ready for. The answer I want is exactly the opposite of the answer I got when I looked up that number. So I just do 1 minus that. That's got to be the rest. Is that cool?
Yeah, thank you.
You're welcome. Oh yeah, okay. I was making sure that was you that asked the question. Okay. So here, what about this bad boy? Let me erase some stuff to make some room. Oh crap, that's fine, Jeff. So what if I ask you? Oh shit, let me ask you the question. Arf. Wait a minute. Oh crap, Jeff. Snarf. So what about if I want to know the probability that z is between negative 1.2 and 2.06? Sorry. Can you first just draw the picture and shade the area that the question wants? Just do that first. The people that skip that step are the ones that are going to make the silly mistakes. And I've had people that can't draw this for some reason and just freaking draw a triangle. It doesn't really matter. You just need a visualization so you can put anchor stuff down, so you can tell, you can approximate things. Get rid of that. Get out. So what goes in the middle?
0.
0. Kick ass. So negative 1.2 is somewhere over here. Holy macaroni, come on. And then 2.06 is somewhere up there. And the area that it wants is where?
The middle.
In the middle, this area here. So how the shit am I gonna do that? Dadgummit. If I look up 2.06, now look what I'm doing here. This is not just me doing my shit. This is me suggesting to you how to do this. Whenever you look up a z-score, you get the whole area below it. So what do you get when you look up 2.06?
.0197.
Whoa, positive 2.06.
0.9803.
Yeah, 9803. I like it. So that's going to be this whole area, 0.9803. Is that more or less area than what I want?
More.
More. Can everybody see that? Does that make sense? Whatever z-score I look up, it gives me the whole area below it. I want it to stop right there. So how much extra is there in this? I got to subtract something out. The exact area that I have that's too much is exactly the area below this stupid dude, right? If I figure out the area below him and subtract these two, I'll be left with the area in there. Does that make physical sense? If I have all this area, I wanted to stop there. Well, if I just subtract this area, I've got it. So it kind of makes sense. Problems that have two z-scores, I'm going to have to look them both up in the chart. Now, of course, I'm going to need your help in the negative one. I think I can do that. Hold on.
Point 1151.
Yeah, so when I look at negative 1.2, yeah, 1151, I like it. Oh, cool. I think that's right where I was before. Okay. Oh, shit. Point 1151. And I really want you guys, one little thing I haven't done a good job at all of at the moment is every single one of these entries is the equivalent of finding an area of a rectangle in a uniform curve. It's just that the shapes that I make when I draw this shape here, I can't handle that shape, right? Right down there. You guys see the shape I'm talking about? Little weird ass freaking melted triangle dude down here, right? I don't have a freaking geometrical formula for that. Freak, that's the word of the day. So when I look that up in the chart and get that number, that is the equivalent of getting the area of a rectangle. That I can do without a chart. I can do that. I know the formula. I don't know the formula for the area of this. Well, let me go look at the list of all answers of areas. That's what this is. So I don't know if that helps you make sense of what I meant earlier. This is a list of answers. You just have to know where to look. So how the shit do I get this again? I haven't gotten this answer yet.
You subtract.
Subtract. So 0.9803 minus 0.1151 become a 9. Okay.
0.8652.
8652. Yes. Ooh, I like it. Sound like that's a 6. So 86.5% of this is in here. All right. So I'm going to give you a minute just to finish copying down what you need from there, and then I'm going to stop. I'm going to clear all this crap out the way. All right, I'm going to clear all that stuff because I want to do one more example, actually, now that I'm thinking about it. There's always an example I forget to do. This is the first year in a long time I remember to do it. And you're like, good for you, Jeff, but it's going to help you guys out. All right, I'm going to clear all that away. Bye. Okay. What about this question? What question, Jeff? I don't know. I'm going to move up here just because I want to. All right, this will be good. Did you really have to, Jeff? No, but I'm just wanting to. So can somebody tell me, can somebody find the z-score for, oh, you're going to love this question. The z-score for whatever the shit, let me pick a good one. Sure, whatever the shit, yeah, there we go. Let me write that in a different place. Z-score for this. What the hell is that?
$25th percentile?
No, you're thinking Q1. That is P1.
Oh,
So you're correct. It's the percentile. It is the first percentile. Yes. Which means what? And by the way, this is all in a normal, it's got to be in a normal distribution. So if I don't know the distribution is normal, I cannot use this chart. So I know it's normal. Where would that be in the distribution? Where would the first percentile show up? What does it mean? What does the first percentile mean?
The first z-score away from the mean?
No.
Only 25%?
We talked about percentiles way before we talked about z-scores, right? So if you scored in the 80th percentile in a test, that means what?
80% scored below you.
There you go. So P1 means what percentage is below it?
0.
No.
1%?
1%. That's all, isn't that? So maybe I picked a bad, I just picked 1. I'm sorry, because that's going to be easy to find in the chart. But if I would have said P80, it would have been the z-score that has 80% below it. Because that's what P80 means, the thing that has 80% below it. So what's P1 mean? The thing that has 1% below it. Stay with me now. Notice what I keep doing. What are the numbers I keep putting up here? Every number that I put up here related to the what? I wish I would have done this when I still had all the other problems up here still, but every number I'm putting up here is something, and every number I'm putting down here is something else. Every number I'm putting up here is an area. Every number I put down here is a z-score. So I cannot find this answer by going and looking up 0.01 on the positive z-score. This is not a z-score, that's an area, it's a percentage. So what we're doing is exactly the opposite. What were we doing for every problem until now? We were looking up a z-score here and getting it here, and then looking up here, and then coming to something in the middle, bam, and we got it. So now I've got the percentage. Oh, I see. All right, we'll get there. You're right. You got it. Can you find 1% in here somewhere? So I got to start inside and then look out. So if I know a z-score, I go from the outside and look in. That's an area. That's a percentage. That's going to be in here somewhere. So where's the closest you can get to 1%? 0.01. Where's the closest you can get to it? Oh, that's 100%, Jenna. Right? I want 1%, 0.01. What's the closest you can get to 0.01 in here? Right. No, I don't know if you guys, The minute you see it, you'll get it. There it is, okay? So look, isn't it? Look, aren't I? Oh, there's 0.0107, there's 0.01, but that's a little closer, right? That's 0.0104. Wait a minute, that's even closer, 0.0102. Wait a minute. That's the freaking closest I can get right there. Isn't that the closest I can get to 0.01? I love you guys. 0.01 is 0.100. So isn't 99 closer to 100 than 102 is? Right? So that's the closest. So what z-score is this for? I've already got the answer chatted to me a couple times. What z-score is that?
Negative 2.33.
Negative 2.33. Do you see how that's the exact opposite of what we did before? Before, I started knowing the z-score, and then I looked it up, and I looked inside and found the area. Now I start knowing the area. Okay, I got to find it in the body and then look out to find the z-score. I have to be able to go both ways. And remember, I mean, this is the first day we're using this shit, so just don't freak out if this is not making 100% sense yet, right? All right, so what I want you guys to do, nobody told me you couldn't access this. So I'm gonna assume that's true. I'm gonna erase all the stuff that I've done. It's gonna go away. Bye. I want you to go, so get this, you might wanna print this bad boy out if you can for yourself. Go to modules, and go to the same module where we found that. Go to Unit 6, Normal Distribution Practice. Bam. Uh-oh, somebody's shouting at me. Oh, you don't have to. It was just a suggestion. You don't need to right now. You just need to be able to access it. So I want you to do this first problem right here. When I say first problem, I mean the first 5 problems, right? A, B, C, D, E. And I'll just sit here. Maybe I won't record this part. Can you pause, lady? What? So when you look up 1.18, when it says less than, it kicks so much ass because that's what the chart tells me. What do you guys get when you look up 1.18?
0.8810.
Yeah, let's see. Let's double check. So 1.18, yes. 8810, kick ass. Oh, thank God. All right. So that's the answer. So some people get a little overzealous with when they have to adjust the answer they get from the chart. The chart tells me the area below. So if the question wants the area below something and that's it, that's a one-step problem. This could be a two-step problem, depending on if you like the shortcut or not. But if you don't use that shortcut, look up negative 0.52. That won't be the answer, right? But somebody else, tell me, did you look it up? What did you get when you look up negative 0.52?
0.3015.
0.3015?
Yes.
All right, and that's what everybody else got? I'm gonna crowdsource that. So what's the right answer?
985.
6985. Kick ass. And those of you who like the shortcut, you're like, oh, there you go, you caught up to me. Good job. So if you looked up positive 0.52, you can get that right away. All right. I get people that just start doing 1 minus every damn thing. I guess they figure at some point it's going to be right. But just see why it makes sense when to do it and when not to do it. So in this problem, Whenever I need to find the area between two z-scores, it's going to involve subtraction. So I got to find the areas first, and then I can subtract them. So if you look up 1.49, what do you guys get?
0.9319.
9319? Does that sound all right to everybody? All right, confirmation. And if I look up negative 2.63, what would you get?
0.0043.
0043? So then the actual amount in that little area will be the difference in those two, just like we talked about earlier. So whatever the hell that is, I don't know.
0.9276.
9276, okay. So right now, these are disconnected from the real world. These problems are all just getting us to understand how to read the chart. Like number 2 is going to be a more real world problem where I have to create z-scores first. So this currently doesn't mean a damn thing to us. But if this was a test and the mean was something, and then somebody had this z-score for their test and somebody else had this z-score, what percentage of the students scored between those two grades? Almost 93%. So they're not all going to be physical problems. This is just getting used to the chart. Now let me help you with part D. I don't know how many people have started part D. Where should I draw the line for where the z-score is? That is weird. What does that do? Sorry. Does anybody? So if I wanted to draw the line that represents this, the z-score for this, where is it going to be? Up here? Down there?
Left.
Why is it going to be down here? Because it's only got,
Decimal.
it's only got how much below it?
38%.
38%. Yeah. So I know, oh my God. I know that it has to be, let me salvage that number. I know it has to be on this side of the mean, because what's the mean always got below it in a normal curve? The mean has always got what percentage?
50.
50. So I know it's got to be here somewhere so that this is only 38%. Therefore, I know it's going to be what kind of z-score if it's below the mean?
Negative?
Negative. Kick ass. So now you know which one to look at and see how close you can get to 0.38. Don't say it out loud yet. I don't know if everybody's tried this problem out yet. All right, my scribble's going to come with us, but too bad.
Hold on, just a clarification question. So if it's below the mean, which is 0, then you're going to look at the negative z-score charts?
That's right.
Okay, and then if it's above 0, you're going to look at the positive ones.
That's right. So please, please recognize that this is a normal number line, right? If that's 0, then this side's negative and that side's positive. And it's just because the way we created the z-score formula, a negative means below average, just because of the way we designed the formula. So if I look back over here, I'm sorry, I can't get rid of my scribble. What's the closest you can get to 0.38?
0.3783.
Good. Let me see if you guys see this. This is 21 away from 0.38. You guys see that? And this is 17 away from 0.38. So I don't know if you guys see that. One of those two is going to be related to the answer. That is 21 away, and that is 17 away. So that's the closer one. if somebody really wanted to, you could actually take the average of those. So this would be negative 0.30, and this is negative 0.31. So your answer could be negative 0.31. That's the z-score that has this. Or it could be negative 0.305. Split the difference. If you don't like that, don't do it. Isn't it almost right in the middle of those two, right? 0.38, isn't it almost right in the middle of those two? Are you guys with me? So I could actually do the middle of 0.30 and 0.31, and that would be 0.305. Do you have to do that? I just said no. You can pick the one that's closest. So that would be negative 0.31. So I put that right there. Jeff, you actually have to turn the thing on. I know. Leave me alone. Negative 0.31. So how far down from the mean do I have to go before there's only 38% left below that? Is almost a third of a step. 0.31 steps below the mean is where there's that much left. Okay, maybe.
Is it negative 3.1 or?
No.
no,
So, do you see how it's negative 0.31?
Okay, I didn't see the point.
Yeah, 0.31. Yeah. Okay. Now, E is very similar to D, but it's not a percentile that it gives me. It says 10% above it. So that, where would I draw that? The z-score that has 10% above it. Zero's not in the middle. It's driving me crazy.
To the right of the zero, like a little bit.
Yeah, actually a decent amount. But it doesn't matter. As long as it's over here somewhere, because it's supposed to only have 10% above it. So if you put it down here, that makes no sense. It's going to have more than half above it. It's going to have to be over here somewhere. Does my chart understand this area? Does my chart understand this area? No, the only kind of area it understands is where? Below. I love it. Of course, that's how it's built. That's how the dang thing is hardwired, right? So what area is below that z-score if 10% is above it?
90.
90. All right, so if you haven't looked this up yet, go ahead and do it. Don't say anything if you have. I want you to discover this on your own. This is so exciting.
Oh, I see what you mean.
All right, let's take a look. Have you guys discovered something interesting? And again, I'm sorry about my scribble, but oh well, it's too bad. When you try to find 0.90, where are you? There you go. When you try to find 0.90, what happens? Where can I put you? Here we go. All right.
How come we look on the positive one instead of the negative one?
Oh, let's go back here. Is my z-score above or below the mean?
Oh, above.
Yes.
Okay.
Yeah, I like it. This is where the interesting happens. No? Oh, I guess not. That's right. Darn it, Jeff. Why did you make it 90? That's silly. All right. So something interesting doesn't happen. I'm sorry. It's kind of boring. What's the closest you can get to 0.90? Somebody's chatting at me. Yeah, you got it. So the closest I get to 0.90 is 0.89. This is getting good. There's some 0.90s. There's two. Oh, shit. There we go. 0.89, 0.8997. Look at that. That's as close as I'm going to get right there. This one. You guys see that? That is the closest I can get to 90%. 0.8997. What z-score is that? 1.28. So this is 1.28. Any questions? Please let me know if you have a question. Please. I can sense questions. I can feel them out there.
So when you're looking for, like for E, when we're looking for which value is closest to 9.0, yeah, are you just basically just looking down the chart, and then once you find the closest value, then you look at what the z-score is?
Yeah, because
okay,
normally we look up a z-score from both sides, and we come and then we get an area. So now I've got an area. Once I find it, I look out this way, 1.28. I can piece the z-score back together. So it's a z-score of 1.28. So another way to look at this is, how far above the mean do I go until there's 90% below? I go a little over a step. I go 1.28 standard deviations up. So let me see if I can combine this with something we just did. So let's say that, let's do the right numbers. Sophia, we hear you. The mean is, that's all right. I feel the same way. The mean is 69 for American men heights, right? We just did this a minute ago. Standard deviation, let me use the right number here, 2.8. How do I find this height? How far away from the mean is this? I just said it. What does this represent?
Standard deviation.
The number of standard deviations from the mean, right? So if I start at the mean and I go up 1.28 of these, I will get to that height. This is how I convert it back into, in this case, a height. I go from I do what this says. This says this is a z-score of 1.28. That means that's that many standard deviations above the mean because it's positive. So if I start at the mean and I go up 1.28 of these, of the steps, I'll get to that height. So what height is that? Anybody?
72.584.
Like, so 72 and a half roughly, right? So that is, where'd my brain go? There it is. 72 inches is 6 feet, right? 72 and a half inches, so 6.5 inches. So 10% of American men are taller than 6 foot half an inch. So if I had a door that was 6.5 inches tall, what percentage of men would have to duck to get through that door? 10%. So this is actually, you can design a door height to control the number of complaints you might get about that door, right? Somebody's leaving out, so you guys, boom, and they, crap. So Maybe. So that's kind of like the next level of what these are useful for. I can figure out hip width if I want to be politically right, or just how big somebody's butt is, the average size, and I can figure out how wide to make an airplane seat, and I can control the percentage of people that won't comfortably fit in an airplane seat, right? If I design it accordingly. Does that start to make sense? So that's the way you can use these z-scores and what they mean. The problem is, what's the only kind of distribution that chart works for? Normal distribution. And not everything is normally distributed. All right. So a big part of statistics involves determining if a distribution is normal enough. Because if it is, I've got a chart of all the frickin' answers. That's awesome. I just got to look them up. If it isn't, shit, I'm going to have to do something else. It's going to involve a lot of work, and damn. Okay, maybe. I just want to do one of these down here, and then I'm going to let us out. How do you guys feel about this? I've sort of fallen into this pattern of not giving us a break, but leaving early. If anybody ever needs a break or something, just let me know and we can take a break. But I have a tendency to just keep going and then leave early instead. Okay. Let me clear all this. I'm going to clear all this mess. Why am I doing it here? That's the problem, Jeff. Oh, well, that's all right. It's too late, buddy. Just keep going. All right. I could have done it a different way, but oh well. Barf. So let's see what you have retained from what I was just talking about. What's going to go? So read through this real quick. I'll full disclaimer, this is not from a study. This is from my imagination. So take that as you will. This is back in the day when we actually drove to this place called campus. What's going to go right in the middle?
0.
No.
0.
33.74 minutes.
What always goes in the middle is the mean. Why were these 0 up here? Because these were z-scores, and the mean of z-scores is always 0. Another way to look at it is, whatever the mean is, when you make it a z-score, it becomes 0 because z-scores are the distance from the mean to a data point in standard deviation, and the mean is 0 away from itself. All right, so now I don't have z-scores. I have time spent looking for, and the mean is 33.74. That's going to go right there. So where does this go? Where does 27.2 go?
Below the mean.
Yeah, down here somewhere. And then I want the area. I want to know the probability, which is related to the area. So that's less than. So I want that little area right there. Now, I cannot look up 27.2 in the z-score chart for 2 reasons. One, it doesn't go up to 27.2. But more importantly, that ain't a freaking z-score. So of course I can't use a z-score chart for this. Who remembers the z-score formula?
X minus mean over standard deviation.
Kick ass. So we have all of that information, don't we? We know what the mean is. I know what my data point is, 27.2. That's always the data point I'm interested in, minus the mean, divided by standard deviation. You would think I could write straight. On the board, I'm always writing crooked. Just can't. And then whatever the hell that is.
Negative
Like
0.7578.
I don't know if somebody was talking to me. Couldn't hear you.
Negative 0.7578.
Yeah. So negative. Now, how many places am I always going to make z-scores go to? How many places will I always round z-scores?
4?
How many places does the chart go to?
4.
No. Come on. That's percentages. How many places does the z-score chart go to for z-scores?
2.
You guys see that? So the probabilities are all 4 places. I agree with you. But the z-scores themselves, the chart only goes to 2 places. So now if I look up negative 0.76, there's nowhere safe to put this. Negative 0.7, where's 6 over there? 0, 1, 2, 3, 4, 5. Oh yeah, it is there. Do you guys see that? What do you guys get when you look that up? If you look up negative 0.7, is everybody cool with a negative 0.76? Uh-oh, okay.
I think it's 0.2236.
Yeah! So now that has a physical, real-world meaning. A little over 22% chance that a student will find parking for a whole week less than 27.2 minutes. Whew. All right, so each one of these is the same kind of problems. Yeah, that's the one. This is the formula to convert any raw score. What do I mean by raw score? Times, turtle lifespans, grades on a test, salamander tail lengths, whatever the shit you're studying, whatever that data point is, I can subtract the mean and divide by the standard deviation to find a z-score. But the only time I can look that up in the z-score chart to get an area is if it's a normal curve. Okay, I like it. What was I about to say? Oh yeah, so like this one is more than 53, right? So it would be up here and this area. So when you make a z-score out of that and you look it up, you're gonna have to do 1 minus, right, to get the other area. And then this one is gonna be between 15.5 and 29.5. So that's another one where you're gonna make z-scores, look them up, subtract the areas. All right, well, let's do this. We'll finish that up next time. So if you wanna do those, you can, or you can just start doing section 6.1. We just basically did 6.1 and 6.2. 6.2 is if they give you a raw score and you have to use this formula, and 6.1 is all about z-scores. I like it. All right. So I am officially saying that's the end of class. Oh, what time is it? Yeah, your quiz is accessible now. So you have until tomorrow at 4 p.m. And I gave you, let's see, can I find out? I gotta stop. I'm gonna stop sharing. Is anybody still copying something? No, okay. I gave you until, no, I gave you how much time? I gave you 1 hour and 5 minutes. I like it. Yeah. And it's due by tomorrow at 4. All right. So let me know if you have any questions. Do we have until Sunday? I don't know. Oh, by the way, the formulas are on the quiz. It says that there. That's what you can use. You can use the formula sheet on the quiz. What was the question? Do we have until Sunday to submit? I don't know. What's it say in the October 3rd and October 4th are the due dates for section 5.1 and section 5.2. I just recently woke that up in Canvas, that's where you turn in chapter 5 homework. I had programmed them in and then I forgot to turn them on. Now you can see them. Of course, yeah, go ahead.
For chapter 4.3, number 88, can you just help me go over letter E, I believe? No, I'm sorry, F.
All right, do it again. Section what now? Chapter
4.3.
4.3, number
88.
88, okay. You too, have a good weekend. All right, let me see. Okay, so this is the one about the Vietnamese New Year. And which part again, I'm sorry?
Letter F, I don't know why I get confused when I don't know if I should do, if I should find the probability of 2 through 12 students, or I forgot the other way around that you do, that's easier.
Oh, okay. I don't know. Let's see. October 3rd is Saturday, it says. I don't know why you think it's Friday. All right. Let me see. So this one here. So how did you do part E? If your question is about part F, I'm curious how you did part E.
So part E, let me see. Find the probability that I moved 4 students. So I did. I pretty much found the probability of. Okay, so what I did was.
Yeah, what does that most 4 mean? What does that most 4 mean?
4 or less.
Good. So you would do 0, 1, 2, 3, 4, and then add all of them. I like it. So you need a formula for each one of those, and then you add them all up. I'm not going to do 1 minus because that wouldn't make it easier. The opposite of this would be 5, 6, 7, 8, 9, 10, 11, 12. That's more work.
Yeah.
But look at this one. Greater than 2 is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my God.
Yeah.
So I'd much rather do 1 minus the probability of everything this leaves out. So what does that leave out? 3, 4, 5, 6, 12. Starting at 3 and going to 12, what have I left out? What values?
So
you know all the values you can take on, 0, 1, 2, 3, up to 12, right?
Uh-huh.
So if this is 3, 4, 5 up to 12, what values did that leave out?
1, 2, 0, 1, 2.
Yeah, 0, 1, 2. And notice, so if I do this, add them up and take it from 1, I'll get that answer. I'll be done with it. So when do you want to do the 1 minus thing? When the opposite situation has less work. And notice for part E, you've got to do those anyway.
Got it.
So for part F, you're just going to add that part and take it away from 1. You've already finished part F when you do part E. Yeah.
Okay, perfect. Got it now. Thank you so much.
You're welcome. Everybody else, you guys all right? Anybody need help? Are some of you guys really not here? You checked in and then you left. What? Let's see. Diana, Michael, are you out there? I'm gonna head out. I really need to figure out halfway through the class to see who the hell's really here, because this is kind of silly. So I'm calling you out. It's on the recording. You got to stay in class.